So thank you for joining our webinar, Taming Excel Hell. What we're going to do going through this presentation is articulate how we can get a little bit more control over Excel. One of the things that we've found for the last 15 years is that Excel is the predominant analytics tool that's used within organizations, and it takes up an astonishing amount of time within our customers' organizations. And one of the things that we find we can help our clients do is accelerate their Excel processes and take a lot of time out of their workflow. And we'll talk a lot about that as we go through the webinar today. The agenda. I'll do some introductions. I'll introduce myself. I'll talk about the problem. I'll do a demo. I'm going to do a hands-on demo on some data. And then I'm going to talk about how we see this as a first step to data science. One of the things that again, we hear from our customers is that a lot of the analysts in our customers' organizations tend to be budding data scientists, but they spend so much time, what we describe as turning the handle, that they don't have the time to actually do the advanced analytics that would really add value to their organization. And so we think sort of this accelerating out of Excel gives our customers the opportunity to do more in data science and do more in the advanced analytics arena. And we'll talk about how this fits, how the demo that you'll see fits into that broader conversation, the broader strategic analytics workflows that our customers are engaging in. Then we'll talk about next steps, and then at the end we'll leave between 5 and 10 minutes open for question and answers. If you have questions during the conference, I've muted everybody, but if you have questions during the Q&A, or if I say something, or if I go too fast or something like that, just ping it in the chat channel and I'll try and pick it up as we go through the process. All right. All right, so introductions. A little bit about myself. My name is Zachary Zeus. I've been working in the analytics industry for more than, well, it's scary now, but about 20 years. I have been running BizCubed for 12 years, and we focus on analytic solutions that are open, scalable, and powerful, as well as being easy to use. We think that it's important to increase the number of people that are actively participating in a core analytics function across an organization to drive analytics as a capability throughout the organization. I've been passionate about that for the last 20 years. And a bit about BizCubed. BizCubed, we call ourselves a better decision-making company. We help people make better decisions each day. Again, we do that by really focusing on increasing the number of people that participate in the analytics ecosystem. We know that that in a lot of organizations, there's the analytics team, the big data team, the BI team, that's kind of driven out of the technology side, and then there's the business analysts and the business teams that take some of that data, but then they blend it and mesh it and combine it with a bunch of other data to actually get the operational reporting that the business uses to make core decisions. We know that there's a lot of manual processes that sit in between decision makers and the data, and those manual processes are fraught with error, and they often take up a huge amount of time. And so we look at how we can decrease that time within an organization to accelerate decision making, to help people make a little bit better decisions each day. Now, the problem we sort of see, and this is it's a little bit stylized, but I'll walk through it. The point of this is to sort of put the context around the demo that I'm going to see, so that you can sort of put this into a frame which may be similar to your day-to-day life. Now, the point about this is analytics is actually hard. Data is hard. The way in which we want to view and see information isn't always, in fact, often isn't, the same way that the information is stored, collected, and managed within the organization. And so there often is a lot of manipulation that's required to facilitate putting the information in the context that a decision maker or a person can actually consume and make a difference with. One of the things we talk about is at 9 a.m., the C-suite, the CEO says, "Hi, I've just invested X million dollars on an analytics solution. I surely should be able to get the answers I need to answer the questions I have about where the business is headed. So I'm going to ask my team and see if I can get the information I need." From the GM's perspective, the CEO has just spent a bunch of money on this analytics stuff, but it only covers a small portion of my reporting needs. My business area, my business unit is moving much faster than my analytics team can keep up. But I'm not going to let the CEO down. I'm going to get him the information that he needs. So let me go and see what we can do to get that data. I'll go to my business manager who's running the unit that was asked about and see if she can provide that information. She's asked the technology team to provide more and more robust information, but they're unable to respond in the timeframes that the business requires. And the reality is business is moving so much faster than our analytics teams can. So I'm going to go to my data guru, my analyst, and see if he can get the information that we need, and so put it together in a way that I can give to the GM. Analyst, well, here we go again, a new request. My boss needs information to prove the value of what our business unit does. The C-suite and the GM both have unrealistic expectations about what we can do with it. But my boss said we'd get it to them by tomorrow morning at 9 a.m. So here we go. First, I'll collect the data. Then I'm going to use a mix of Excel, lookup tables, a bunch of data from a lot of different places. I'm going to download it, copy and paste, munge it together, maybe do an API call using Postman or something like that, and then I'll do some filtering, cleansing, and row removal just to clean it all up. But this is going to take some time. I work on it for a couple of hours, and then I've been working, and now Excel just crashed. At least I know what to do, so it should go faster. Oh, and by the way, I haven't saved in the last 2 hours, so I've got to start over. But I kind of know what I'm going to do. 7, okay, data's starting to look good. Let me get it into Tableau so I can start doing analysis. Damn, I forgot the fields from the new process we have been testing for the last 6 weeks. So we've added a new business process to our operation. So I've got to go get that data from Excel. So I've got to go back to Excel. Now I'm getting close, but I'm going to go home. It's 8 o'clock, but I'll come in early tomorrow so that I can put the data together in a more cohesive format. Start at 7, need more coffee. I was talking to an analyst about this scenario a week or so ago, and she told me, well, typically we take this work home with us. So I would have been doing work at 9, 10, 11 o'clock, up even earlier to get this done in reality. But 7 o'clock need coffee, 7:15, still not awake, but it better get stuck in. Okay, the data's okay, start working with it. Oh no, I forgot that we have a process problem where our workflow isn't quite capturing all the data that we need, or it's not showing it accurately. Only way to fix it is to go and manually remove records from the data set. Back to Excel. 8:30. All right, now it's starting to look good. Oh no, I just realized the numbers from May are wrong. It's too late to go back to fix them. I have to get the report to my boss for 8:55. I know what they should be. I'll just manually change them. Wow, the numbers look great from the business manager perspective. Just what the CEO needs. Let's take them up and show them. The main numbers don't match up. Why did I spend so much money on the analytics solution? And so what this is showing is there's a bit of a discontinuity from the expectations in the C-suite versus what our organizations can deliver from an analytics perspective. And there's a mismatch in the expectations from the executives on how the information actually comes together and what the real workflows look like within our customers' organizations. So what's the problem? So Excel is the wrong tool for the job. It's not repeatable, not scalable, and it becomes difficult to explain what is happening. But what's really the problem underneath this is that there are 2 different workflows. There's the analytics workflow that where all the investment is going, and then there's the Excel workflow that is sort of getting left behind. And so what we focus on is how we view analytics work processes as a automatable and repeatable process to allow the day-to-day Excel processes to roll into the larger scale analytic solutions that is getting the investment. So we'll talk about that, and we'll show the tools and how that comes together. Some solutions I've seen, of course, we've talked about Excel, but people then start using Python, scripts, VBA, SAS, R, DB scripts, stored procedures. There's tons of solutions in the space, but what's challenging about most of these is it hides the complexity, or it becomes difficult to figure out what's going on 6 months down the line if you have to redo some of the work. What we like to do is look at where we spend some time and see if we can automate or increase the rate at which the time goes. So some places where we spend a lot of time is combining data from multiple sources, doing lookups on large lookup sets, removing duplicates, inner, outer, left, right joins. Sometimes it's difficult to know what any of this means. Massaging data from the raw form to something more useful for reporting. And because we are often doing this in Excel, the performance of Excel does not scale to the data sets and data sizes that we're facing nowadays. So now I'm going to go into the demo and show how we might solve some of those problems that we've seen here. All right. So going over to the demo. So this is what we're going to build, but I'm going to start from scratch. So this is the Pentaho data integration screen. I'll talk a little bit about this tool when we get towards the end of the conversation. And this is the welcome screen when you come in, where it talks about working, learning, extending, or upgrading. So we're just going to start work, and we're going to do a new transformation to start off with. So the first part of this use case is I'm going to get some data from a couple of text files and combine it together. So I'm just going to come over here and hit text, and I grab text file input. Now I'm going to go get data from my desktop. Where I've put my Taming Excel demo. I'm going to select that. Now I want both of those files. So what I'm going to do is I'm going to take off the first part, click add, and do a regular expression to say get all of the files in that directory. So .star is the thing. That's kind of the most technical thing we're going to do. And we see it's getting both those files. It's also getting, it's also getting a .ds store. There's nothing I can do about that. Well, I actually can do an exclude .ds store over here. I'll just do that. So if I show file names now, I see just the two files that I'm looking to get in the from there. Now, what's interesting about that, and just show Taming Excel demo, if there were, in fact, what I'll do is I'll just do this. What we see is just by adding that, we now have all three files in there. So we'll just add that there. So it will read 3 files instead of 2. Go over to the content. This is where I set whether it's a CSV, what type, enclosures, different types of things. We also can do tabular formats and a bunch of other kinds of things, put some error handlings, filters, a bunch of stuff, but I'm just going to go get the fields. So I'm going to get the fields. I'm going to sample 1,000 records just so that we make sure we get the correct data type in here. So basically it's looking at the data to determine what type of data it is. And that's the analysis it's done. I click close. I can now preview the rows so I can see what I see. And I see that there's 1,000 rows here, right? I can see the data. Now I'm going to click close, click OK. Now one of the things I like to do as I'm going through this process is I like to see the process running over and over. And I'm looking for the wrong one. I want the dummy step so that I can do a bit of a breakpoint and I can start seeing the data. So dummy here. Well, the other thing I like to do is name each step. So get text file data, view the data. Now I've got to join these together. So I'm just going to click on here, hit shift, click and drag. And now if I hit the preview button, I can do a quick launch and see the data flowing through. Now, one of the big benefits here is I can see the data flowing through every step of the way, and I can see that the data is coming together correctly or not, depending on what I'm looking for. So view the data, and now if I just look at the data, I can also preview the data down here, just at any step. One of the things I want to do is I actually want to add the capital city of these states to here. So what I'm going to do, I don't have that data anywhere, but we only have a couple of states. So I'm going to do a quick mock-up of the data I need. So grid. So data grid gives me the ability to just add data directly. So what I'm going to do is I'm going to add two types of fields. I'm going to add the state code field, call it a string, and I'm going to add the capital city string. Now over here, those two columns are available. So state code, I'm going to go Taz, Hobart, Queensland, Brisbane, ACT, Canberra, SA, Adelaide, WA, Perth, NSW, Sydney, Vic, Melbourne. And I'm forgetting one, which is Northern Territory, Darwin. I think I'm good there. But if I look over here at the data, there's some that are undefined. So I'm going to add an undefined, just say unknown. Okay. And so what I want to do is I want to join the capital city with this data stream. So I want to add a column over here. So I'm going to do a stream lookup. I could also do a join, but the stream lookup is the best choice in this case. And I know that from experience. But there's lots of different choices on how we manage data coming together. So stream lookup. So I'm going to drag the hop into there and drag this one here. So actually, before I do that, let me just do list of capital cities. And the data's still here, right? So stream lookup. I'm going to get list of capital cities, get fields. So I'm joining on the state code. I name them the same so that they be the same, but the lookup field has only the two fields from this one, where the field one has all of them from the other one, so many more. And then I'm going to get the fields to retrieve, so get lookup fields. So I only want to get the capital city. Click OK. Then I'm going to do a new dummy just to preview. Because I always like to look at the data as I'm building, so I know that I'm getting it right. So this is at view capital city. Preview, quick launch. So I can see that the capital city is all going in correctly. Cool. Now the thing I want to do is maybe I want to, instead of viewing all the records, so if we look at the step metrics, we can see that there's a bunch of data coming in so far, 3,000 rows from my 3 text files. We're actually going to see much bigger numbers there in a few minutes. But what I really want is maybe the count of customers. So if we look here, this is sort of dummy customer data, sort of generated customer data. Maybe I want the count of customers grouped by capital city, for example. So let's look at this group. So I'm going to choose the group by step. And I'm going to group by the capital city. And I'm going to count the customer number. And I've got lots of different options here, but basically number of values n, so count. And then I can preview here. So what I'm going to do, instead of previewing, I'm actually going to run the whole thing because in order to view the group by, it's got to actually process all the data. So I'm going to hit save, call it webinar demo actual. I'm going to click run. This is actually going to process all the records. And so while it's going, I'm going to grab over here and so I can see how that's all going. And what I see here is I'm reading in 400,000, 500,000 records. We're running at about 60,000 records a second. When we get done, we see the memory group by reread 1.2 million records. We have 9 rows coming out of there. And if we preview the data here, we see that the capital cities have a distribution. And one of the things when I look at this that I see is that Sydney and everything else has kind of an even distribution, but Sydney and unknown have kind of are clearly missing the records, and really probably unknown should be Sydney. I can kind of do that by just looking at the distribution. So if I go in here and change capital city from undefined to unknown, just change that to Sydney. So it will take the ones that I don't know about and mark them as Sydney. I then can click run again. Check out the step metrics. While that's running, just so some of the things you can see, we can see we're running 80,000 rows a second. We're seeing so basically it's the text file is writing out 1.2 million records, but it got in from an external source 1203. Now that extra 3 was actually the header row of the CSV file. So basically, and that's why it's showing that separately, and it's only passing on 1.2 million, and the view the data here is getting that 1.2 million in and writing out all 1.2 million. And then the memory group by got 1.2 million in, but only wrote out 8 records. And if we look at the data here, we can see, yep, they're all sort of an even distribution there. The other thing just to look at is, oops, it's not the thing I wanted to click on. But we can also see the logging data of what's going on. So we can just see how all of that's processing. But the key thing here is we were able to process 1.2 million records, do a lookup, change some data, and get it all in about 15 seconds. But now, this isn't in any form I can necessarily use it. So what I'm going to do is I'm going to export it to another format. So I might need to get this into Excel. So I'm going to, oh my goodness, sorry about that. I'm going to take a Excel output and send this to Excel, so that maybe I can then use this in another an analytics piece. Now, the important thing about this is I don't have to send this to Excel. I could send this to a database. Let's just look at all the different options we can send it to. I can send it to a table, which is a database. I can do some synchronize. I can send it to Salesforce. I can send it to Amazon in S3 buckets. I can send some JSON output. I can send it to a CSV file. You name it, we can kind of send it out to. There's actually a lot more when we look at the big data stuff. So we can send it to Hadoop clusters, to Mongo, to Parquet, to Avro. We can kind of send it almost anywhere, Cassandra. But right now we're just doing a use case because we're trying to tame Excel right now. So I'm now going to hit, I've got to tell it where to put it. So I want to put it on my desktop. So demo. So demo, and I'm going to say put a date in the file name, so because I might want to run this every day. Click OK. I'm going to click run again. While that's running, I might just, let's look at the step metrics again. Look at some of the other sort of cases that we might have. So if we have duplicate rows, we can use our unique row step. If we need to cut a string, we have a strings cut step. combining fields. We have a calculator step to do advanced calculations. We have a formula step, which gives us the ability to do Excel type calculations. We can really convert data into almost anything. So now I've done an Excel output, and I can see that it's written 8 rows out into the system. So I read 1.2 million and 3 records in. I've written 8 records out. And if I go to my desktop, I see my demo XLS with today's date. I could also have had the date time on there if I wanted to as well. I open that up, and I can see that I've got this data, and I can then quickly data do a quick chart. Not a very good scale over here on the chart, but you get the idea. That's pretty much the demo. Key thing here is we're able to process a huge number of rows very, very quickly. We have all of the functions that we do that often take a huge amount of time in Excel, and we can make that happen faster. And basically, the idea that we want to get across at this point is that we can accelerate our current Excel processes just by going from text files to Excel. But the key thing to think about after that is this logic where we decided, capital cities undefined means Sydney. That's something that if we were, we can then potentially accelerate the rate at which that kind of logic, that's kind of a simple one, but that kind of logic can get put into our operational analytics. And so we can scale this from our day-to-day Excel-based processes into the strategic analytics function, because this platform and tool scales from hundreds or thousands of rows to millions, which I'm showing here, to billions, and potentially even larger. So we have customers using this platform and tool to process more than 2 billion records a day. There are some customers in the States that are using this platform to process up to 100 billion records a day. So we can really scale out. And so we can go from the day-to-day Excel-based workflows and accelerate those all the way to massive clustered environments. And so as an analyst, we can become part of the broader analytics ecosystem and help drive solutions as opposed to waiting for our IT team to come to deliver for us. So that's the demo. And I'm just going to pause there quickly and just check to see if there's any questions in the chat channel. So if you have any questions in the chat and you want to just push them to the chat channel, happy to entertain them now. But I'm going to move on to the next part of the demo or the conversation. So far, there's no questions in the chat channel. So what did we see? So combining two CSV files, we actually just on the fly added a third one. It could be any number. Looking up and enriching data from another source, so kind of a left outer join or VLOOKUP. And so we just did that in the tool, but that other source, and actually if I go back into the tool, that other source this here could have been a database table, it could have been a CSV file, it could have been an XML file, it could have been a JSON string. Here's all the list of different types of data we can get into the system. It could be a SAS file, SAP file, Salesforce data, you name it, or not files. So these are not files. These are actual direct connections to SAS or SAP or S3. It could be an Access database. You name it, we can kind of get data into here from anywhere. Google Analytics data. If you're in the healthcare industry, HL7 is a key data interchange format. So we got data from a secondary source and enriched our data source. We changed some values. So basically, we changed the undefined to from unknown to Sydney, and then we exported to Excel. And we did more than 1 million records in under 30 seconds. So one of the things I talked about is how this fits into the path to data science. As many of you would be aware, Harvard HBR said that data science is the sexiest job of the 21st century. But one of the things that I find in a lot of our customers is that they're faced with doing too much turning the handle, and they don't have the time to actually get into the more advanced analytics. And what we see is that because we don't have the time to actually focus on the analytics portion, we end up not doing more advanced analytics, and that gets outsourced to sort of separate environments. So the next step, so basically in data science, there's kind of a standard data lifecycle, and it's called the cross-industry standard process for data mining. And basically, what we find is that the early phases, problem understanding, data review, data prep, and transformation, typically account for 70 to 80% of the time and effort. And what we see is that a lot of times that's because the tooling and the knowledge is or basically the data scientists, the people who know the algorithms, don't know the data. And so there's a lot of time spent trying to figure out how to get the data in the right format. And if we can accelerate that, and if we can increase the number of people participating in that process, using a tool like the Pentaho platform, you can actually significantly increase the rate at which data science and advanced analytics can be incorporated into your organization, and you can become part of that ecosystem and workflow. Even more importantly is the deployment. It ends up being the key area that takes the most amount of time. One of my first data science projects a number of years ago now, we basically hired a data science team to build us a model. We had ended up with a fantastic lift curve. And in that lift curve, we saw that we could decrease our call center calls by about 40% and get the same exact results. And so we had paid an external provider about $75,000 to do that predictive analytics for us. But because we were working in a very complex financial services area, the actual deployment of that model ended up costing 10 times as much. And because of the tooling that we've sort of shown here, where we can write data almost anywhere, we can really accelerate that deployment. The places where that gets accelerated is sort of both in the modeling side and getting the model ready, and also one of the things that happens when you go to deploy an analytics model is you actually have to stream together the data sets from many, many different sources to get the lift results. So in the case of the call center I was talking about, we needed to get data from our underwriting system, our good business practices system, our compliance system, our risk system, and our compensation system, in order to achieve the results that we saw in the lift from the machine learning. And in order to blend those together, it was quite a large technology project where if we had done the data modeling from the Pentaho platform, we would have been able to not only accelerate the time that we provide the data to the data science team, we would have been able to reuse that capability and deploy it almost directly without many changes. And the data science capability that's supported is a tool called Weka, R, Spark, and Python, all the major players. And so really can be part of that broader ecosystem using the same capabilities I just demonstrated. So that drag and drop environment is deployable in data science workloads at massive scale. So I did show a tool, and where that came from is it's from Hitachi. Hitachi bought the platform Pentaho. Pentaho is an open source tool, so you can download that from SourceForge. So the demo that I did used 100% open source capabilities, so there's no cost to do what I just did. So we can accelerate your workflows without any charge. And basically, Hitachi brings together sort of an OT capability and understanding that solutions are complex mixes of lots and lots of technology and capabilities with its IT background. And so basically they like to say is that they combine the deep IT and OT and domain expertise to really provide unique value. And they did that, and they bought Pentaho to accelerate that, particularly in the data space, because it's a data integration analytics platform that is embeddable, open, cloud ready. So basically it gives you the big data blending that I just showed you for analytics in real time, and lots of support for big data and scale. And there's no per user licensing. And like I said, it's open, so you can start using it right away without any dramas. So next steps. You can download the tool, so sourceforge.net. So we'll send this around to everybody, this link, and we can register for our newsletter. So we'll send around those things. And I'd also love your feedback on the webinar. So, and that leads us to the Q&A.